Welcome 7th graders. We're on the last lesson of chapter 7. I can find the total surface area of prisms and cylinders, page 386. So I can find the surface area of prisms and cylinders. There's quite a few vocabulary words here. The lateral face of any solid is a flat surface, not the base. So here, because this rectangle and this rectangle would be the bases, the two congruent sides, whereas this and the other ones would be not bases, they'd be the lateral face. Lateral surface area of a solid is the sum of the areas of all of these lateral faces. The total surface area of a solid is the sum of all of the lateral faces, including the bases. So to find the lateral surface area, that's going to be L equals P, capital P times H, where the capital P there stands for perimeter. Okay, so you're looking for the perimeter of that lateral face. Then you multiply that, whoa, we are getting out of shape. You multiply that times the height here. I'm using a little pad to write to see if it's better, and so far we're struggling, but stay with me. So then to find the total surface area, and to find the total surface area here, we're going to be using that lateral, okay, so looking at the symbols, using that lateral surface area we found times the area of the two bases combined. So it's like you're taking this area and you're adapting it to go all the way through the surface. So on the outside and inside more than anything. Okay, so it's kind of like perimeter and area combined is your surface area of a prism. So this is a formula you want to know right here. So keep that in mind, where this stands for the lateral surface area, perimeter times height of one of the sides. Okay. So surface areas of prism. Find the lateral and total lateral surface areas. So what we're going to do is we're going to look for first the lateral. So we need to know the perimeter. So the perimeter of the base. Notice this is our base, and that got highlighted here. Perimeter of our base is at 3 times 7. So that's a rectangle. That's 3 by 7. So we plug in. The perimeter, just add 3 plus 3, or 3 times 2, 7 plus 7, or 7 times 2, and then add them together for 20. So the lateral surface area, so we take our perimeter and we multiply that by the height of 12. So we found out that our lateral surface area is 240 on the outside. So like pretty much all the way around 240 meters. We also need to find the total surface area. I can click there. Total surface area, so we use what we found here, perimeter times height for 240. And we're looking for our two bases. Notice our base, area of our base, that got a little bit out of hand. Area of our base is that bottom piece, which is 3 times 7, or 21. And so we had to find the area of the base and the area of the perimeter of the base. And we're going to put those together, plug in our lateral, and plug in twice our base of 21, work that out for 282. Okay, hopefully this wasn't too confusing of a diagram. I know there's a lot of arrows going on, but that's one way to kind of show you. Another way would just be find the perimeter, find the area of the base, and then plug them into these spots all at once. That might be an easier way instead of finding that and then plugging them in. So water skiing, this is going to be a triangular prism. The ramp of a competitive water skiing is a wedge-shaped ramp that is covered in wax or fiberglass. Find the total surface area of the ramp. Okay, so the total surface area of the ramp. So what we need to notice is that we're looking for the total surface area. So we need this formula. Perimeter of the base, that's why it's capital P. So P is the perimeter of the base. Hopefully we can remember that. P is for, I can't write. P is for the perimeter of the base. Oh, this is not working very well. All right, well, we're giving it a try either way. Perimeter of the base is P. where B stands for the base area. So you need to decide what's the base area. The base of the prism are triangles with a sides of 1.5 meters and 1.5, 1.8 meters and 6.8 meters. Okay, and it has a side here of 7. So this is 7, this is also 7. So the perimeter of that, you're going to add those sides together. So to find the perimeter of the base, we add those together. And we get the perimeter is 15.6. Okay, so the perimeter of just this piece here, the perimeter is 15.6 meters. The area we need to plug in, the area of that same base, because that's what's going to go here, is your area. The area is going to be 6.8 times the height times 1/2. So we get 6 and 12/100ths. A lot of formulas to remember. So we need perimeter and base area of the base. So we use that information to find the total surface area. We plug into those spots. So we still know the height of the figure, the perimeter, which we found, and the base area, which we found. A lot of pieces combined. So our perimeter we found was 15 and 6/10. Our height of the entire figure, so not of just the triangle, but the height of the whole from base to base. Remember, the height is the base to the base. So that's going to be 4 and 8/10. And then our area was 6 and 12/100ths when there's 2 triangles. So we multiply by 2. And we simplify for 87 and 12/100ths. So the surface area of this ramp is 87 and 1200 square meters, because it's area. And that's how much wax we need to cover it. Might be a good idea to check your progress, giving these a try using the formula that you know. So if you can use that formula and do the total surface area is the perimeter of the base times the height plus twice the area of the base. Some of you really may need to write down what does perimeter, what does P stand for, and what does B stand for. So these would be something that we can go over in class. So keep this in mind, and we'll go over those. Give them a try, pause here, and give it a go. Okay, so you can find the total surface area of a cylinder as well. We did prisms, now we're going to do cylinders. By finding the area of the 2 bases, which is a circle, and adding the area to the curved surface. Finding the curved surface is more the difficult part. The lateral area of a cylinder is the area of the curved surface. So if you unfold the cylinder, it really turns out as a net to be a rectangle. So we can use different formulas. So 2 circular bases are going to be pi r squared, and there's 2 of them, so we multiply by 2. Notice that right here. One curved surface is that rectangle stretched out, so it has a width, which is going to be h, its height from top to bottom. And then it's still a circle, so that's just kind of stretched out. We're still looking at the circumference of that circle. Notice we're looking from here to here, the distance around is it stretched out. But those problems when you stretch out a necklace, it turns into a straight line as well. So just with the prisms, you can use the measures of cylinders to find the lateral and total surface areas of a cylinder. So lateral surface area, again, you're going to use the perimeter or the circumference times the height. So again, circumference times the height instead of perimeter, and then doing that same thing for total surface area of the cylinder. Make sure you get those things copied down, and we'll give this one a try. So find the lateral area. So we have to find the lateral area first, which is going to be the perimeter, or rather the circumference. So circumference times height. So you plug in your radius, which you're given. The height from base to base is 3. And you find the lateral surface area of 37.7. The total surface area, you plug in what you found for your lateral surface area, still plug in your radius, and work that out to solve for 62.8. So the lateral surface area is 37 and 7/10 square feet, and this total surface area, including the top and the bottom, is 62 and 8/10 square feet. Labels, finding the labels. So notice we're looking for how much area will the label cover on this can with a radius of 1 75/100 inch and a height of 5 inches. Using some problem solving. Since the label only covers the lateral surface area, that's all we need to find. So sometimes you have to infer from questions what you need to know. We don't need the top and bottom, we just need to know what it covers here. So we could estimate, say, the circumference and round that 1 75/100 to 2, okay, and round pi to 3, so we're rounding a little up and down. So our estimate might be a little bit off, but that's a good test to see what we should be close to. So we plug in what we know, plug in our radius, plug in the height from base to base. Height is base to base, remember. And we work that out for 55, approximately 55 because of pi. So that means that the area of the label is about 55 square inches. Here to some to give a try. The answers are given to you, so it might be a fun idea to try to see if you can get to that answer using what you know about lateral surface area and total surface area. Do remember that for this triangle here, it's going to be, this is going for your lateral surface area. For your lateral surface area, it's going to be the circumference times the height, which is the same as 2 pi r times the height, or it could be, since there's two of them, it could just be pi times diameter times the height if you're given that instead. Then remember that the total surface area is going to be that circumference times the height, or your L, plus twice the bases. And since this is not very clean, since it is after all a circle, that's going to be the lateral surface area plus twice the base, which is pi r squared. Kind of messy, but make sure you have the formulas from those cutouts from the book written down and you know what to plug in and where. So kind of a messy one, getting used to more tools again. Rewatch the video, watch someone else's books, examples, personal tutoring, the online textbook. Check those out.